So let's start section 4.3. This is going to be rational function equations and inequalities. And as usual, I have chosen to make a hilariously unreadable ampersand. Suggested exercises are 1, 3, 7, 11, and 21. And basically we're just going to be going through some applications. I'd like for you to work through examples 1 through 5 in the book. Okay, so here's an application. This is, again, a little bit of a silly application, but let's suppose that at noon, I leave my campsite. Let's just pretend we're not in quarantine for a minute. And canoe 4 miles downstream, that means with the river, or like going with the current of the river, to arrive at my stone skipping spot. This is where you throw rocks at the water at a nice angle with some spin so that they bounce across the surface of the water. After skipping stones for 2 hours, I canoe back upstream, so this would be against the current, and arrive at my campsite at 7 p.m. Now, if I normally paddle about 3 miles per hour, how fast was the river flowing? All right, so this is kind of a weird question, right? I mean, if I'm on a camping trip, why would I be doing math, right? That seems a little suspect, right? You're like, wait a minute, Steve, you're on a camping trip, you're skipping stones, what are you doing with math? I want you to reread this, think about it, and see if we can sort out what to do. So at noon, I leave my campsite and canoe 4 miles downstream to arrive at my stone skipping spot. After skipping stones for a solid 2 hours, so a really short amount of time in stone skipping time, I canoe back upstream and get back to my campsite at 7 p.m. If I can canoe at 3 miles an hour normally, how fast was the river flowing? So normally meaning like if I was just canoeing with no current. All right, well, solution. You might want to pause the video and think about it for a little bit. But solution, we're going to heavily rely on distance equals, equals rate times time. And in particular, I just want to make a side note and emphasize this is average rate times time. So let's let x be the speed of the river, the speed of the current. Well, we've got two pieces of information. We've got the downstream piece of information, and then we've got the upstream piece of information. So let me write the downstream information, and then I'll give you a second to try to write the upstream information. So the downstream information, I know I canoed 4 miles, and I know that I canoe at 3 miles per hour plus the speed of the river. So 3 plus x. And how much time did it take me? I don't know. So I'm going to let that be t, another unknown. Now try to take this. I'll let x be the speed of the river and t be, I guess, the time I paddled downstream. So now try to come up with an equation for the upstream part. Maybe pause the video. Okay, the upstream part. Well, again, campsite didn't move. I still had to go 4 miles. But now I was paddling at what speed? Well, I was paddling at 3 miles an hour minus the speed of the river. And how much time? Well, it was 7 p.m., so it would have been 7 hours, but I spent 2 hours skipping stones and also whatever time I spent paddling downriver. And that's my downstream and my upstream information. Well, I can solve the first equation for t in terms of x, and I get that t equals 4 over 3 plus x. Now I can plug that into the upstream equation, and I get 4 equals 3 minus x times 7 minus 2 is 5, so 5 minus, and now I write in my expression for t, 4 over 3 plus x. All right. So now what I have here is an equation involving rational expressions. So what I'm going to do is I'm going to try to simplify this and get my hands on a rational expression that I can manipulate. Well, I've got to add something here. I've got to add some fractions here. So in order to do that, I'm going to leave the 4 alone. I'm going to leave the 3 minus x alone. But now I need to find a common denominator here between this fraction and this constant 5. So I'm going to write this as 5 times 3 plus x divided by 3 plus x minus 4. So this is 4 over 3 plus x. Okay, so this is hopefully not so bad. This becomes what? Well, if I simplify all of this, I've got 3 minus x times what up top? I've got 15. So that's 3 times 5 is 15. And then I've got 15, then I've got 5 times x. So plus 5x. And then minus 4. So 15 plus 5x minus 4, all over 3 plus x. This leaves me with a final rational expression of 4 equals 3 minus x times 11 plus 5x over 3 plus x. Now, what am I going to do with this rational expression? Well, I have a number of possibilities here, and I'm going to just pause and tell you one thing that I could do is I could subtract the 4 from both sides and get a rational function. I could sketch that rational function, or I guess I wouldn't have to go all the way through the sketching, but I could go through the sketching process and figure out where the zeros are. I don't want to do that now. I want to show you another way to solve this, but I want to just say that at this point, we could subtract 4 from both sides. We'd have to do some more common denominator shuffling, and then we could use the techniques from the previous section to find the zeros of that equation. That would be solutions for x. I'm going to do, since we've spent so much time doing that in the previous sections, I want to use a different solution technique, and then I'll solve another problem with that solution technique. So what I'm going to do here, multiply both sides by 3 plus x, and I get 4 times 3 plus x equals 3 minus x times 11 plus 5x. Now if I simplify both sides, I'm going to get 12 plus 4x equals what? Well, now I've got to FOIL this thing out. I'm going to have negative 5x squared plus 4x plus 33. And things are getting a little bit hairy, but now I notice I've got a 4x on both sides, so I can cancel those. And then if I take my 33 and subtract it from both sides, I'm going to have negative 21 equals negative 5x squared. Okay, and this is nice because I've got negatives on both sides, which means my answer is x equals plus or minus the square root, so I can multiply both sides by negative 1, divide both sides by 5, and take the square root, and I get x equals plus or minus the square root of 21 over 5. Okay, so now I've done the math, right? So I've done the math. Now, x is plus or minus 21 over 5. If I think of x as a physical quantity, then, is x going to be positive or negative? Well, if x is the speed of the river, I'm going to think of that as positive. Okay? However, because of the way that we've worked this out, if I had maybe just been confused about the difference between upstream and downstream, and I had called the upstream downstream and vice versa, then we'd have just a negative stream. Okay? Either way, speed is going to be an absolute value phenomenon, so speed is never going to be negative. That would be speed along with direction. That would be more of a velocity thing. So we're going to say that the river was going then at the square root of 21 over 5 miles per hour. Now we should be a little bit careful and make sure that we're not dividing by 0 anywhere. And the only time that we were dividing by something was with this 3 plus x. So I know that my speed can't be negative 3. That's absolutely fine. All right, so the answer here is square root of 21 over 5 miles per hour. That's how fast the river was moving. And if we think about that, that's a little bit faster than 2 miles per hour, which makes sense, right? Because if it was the square root of 20 over 5, that'd be the square root of 4, which is 2. So this is a little bit faster than 2 miles per hour. And that's reasonable. If the speed of the river was faster than I can paddle, then I wouldn't be able to get back, right? Okay, so when we're doing word problems, when we're doing applications, there's more than just the symbols to keep in mind. Now, luckily, they didn't, these extra considerations didn't affect much, but it's worth thinking about. So I definitely suggest pausing and going back and rewatching this. All right, let's do another example. Remember how I said we could have approached the problem similar to the way that we did problems in the previous two sections, and thematically that might make more sense. So I'm going to do another question kind of using those techniques. So solve for x. X plus 1 over x minus 1 is less than or equal to x minus 3 over x plus 2. Okay, so what I'm going to do here, one thing we could do, we could solve it like this one, where we we multiplied each side by the denominators. We'd end up with some sort of quadratic thing. But then it might be difficult to remember whether we multiplied by a positive or a negative. In this case, it could get a little bit hairy. So we're going to do this one by subtracting. And we're going to say x minus 3 over x plus 2 minus x plus 1 over x minus 1 has got to be bigger than or equal to 0, right? So I just subtracted the left-hand side from the right-hand side. Now I need to do a common denominator. So this is x minus 3 times x minus 1 minus x plus 2 times x plus 1 over, this got a little bit gory, over what? Over x plus 2 times x minus 1. Well, now I need to simplify the top. So I FOIL out the top and I get x squared minus 3x minus x, so that's minus 4x plus 3, minus x squared, now this is plus 2x plus 1, so plus 3x plus 2, all over, and then I'm going to leave the bottom factored. X plus 2, x minus 1. Simplify the top, and I get x squared minus x squared. Those are going to cancel. I get minus 4x minus minus a 3x gives us negative 7x. And then plus 3 minus 2 gives us plus 1 over x plus 2, x minus 1. Now, if I want to get this in the form of x plus something, I need to deal with that 7. So I'm going to sort of multiply and divide by a 7, or however you want to think about this. I'm going to pull the negative 7 out and get x plus 1/7, or x minus 1/7, sorry. And this is the same denominator, x plus 2, x minus 1. All right, now, like I was saying, we don't have to go all the way through and sketch this, but we're going to pretend that we're going to sketch it. So let's set up as though we're going to sketch it, and let's look for holes. So do we have any matching terms on top and bottom? The answer is no. So none. Let's look for zeros. Okay, we have a 0 at x equals 1/7, right? And that makes sense. If we plugged in 1/7 here, we'd have -1 plus 1 gives us 0. And we have vertical asymptotes. So the vertical asymptotes are x equals -2 or +1, right? Those are the things that make these two factors 0. Now, the interesting thing is we don't have to do the whole graphing thing. We don't have to go through the whole procedure. We just need to figure out where this function is positive or negative, right? So we can just build a sign chart, or you can do test points, or you can do whatever method that you see fit. But I'm going to use a sign chart because I think it works pretty easily. And I'm going to list off all of the values of the real number line outside of these special values. So -infinity to -2, -2 to 1/7, 1/7 to 1, and 1 to infinity. Now what are the relevant factors? Well, we've got a factor of x minus 1/7. Oh, I guess I should put these in order, shouldn't I? Got x plus 2. We've got x minus 1/7. And then we've got x minus 1. And this will be where we put our total behavior. So this is x plus 2 is going to be negative until we get past -2. X minus the 7th is going to be negative until we get past 1/7. And x minus 1 is going to be negative until we get past 1. So here we have negative, positive, negative, positive. And from this, we would, sketchy. We'd find the horizontal asymptote, which, just by looking at this, we see the degree of the denominator is bigger than the degree of the numerator, so we'd have a horizontal asymptote at y equals 0. But we don't have to go through all this, because all we care about is where this function is bigger than 0. So this function is bigger than or equal to 0 here and here. So for sure, our answer is going to include the open interval from -2 to 1/7, and from 1 to infinity. But remember, it's okay for this function to be 0 as well, so we need to include our zeros. So our final answer includes zeros as well, so our final answer is going to be -2 up to 1/7, including 1/7, right? Because 1/7 is a 0, and 1 up to infinity. And you might say, well, why don't you include 1 or -2? But the function is not defined at those points. Those points would be dividing by 0. So this is our final answer, and I hope that made sense. And